Let us now do another example from the chapter of circles and solve an exercise problem from exercise 9.3, question number 3. Okay, we are given a circle with the 3 points P, Q, and R as points on the circle, and it is given that the angle PQR is 100 degrees. So that means it's this angle over here that is given to be 100 degrees. And we are asked to find the angle OPR, which is this angle over here. Angle OPR is the angle that we are supposed to find. That's the question mark, okay? So how do we proceed with doing this? First of all, what we notice is that the angle PQR, which is given to us, is the angle subtended by the major arc PR. So this is the major arc PR, which is below the chord PR. So the angle PQR is the angle subtended on the minor arc by the major arc, okay? So 100 degrees is the angle subtended on the circle by the major arc PR. And from that, we will be able to calculate the angle subtended by the major arc at the center, okay? Because we know that from the theorem, the angle subtended at the center is twice the angle subtended at the circumference. So given that we have angle PQR is 100 degrees, given angle PQR is 100 degrees, that means this angle PQR should be half of the angle subtended by the major arc at the center. So that means angle PQR is half of the angle subtended by the major arc at the center, which is nothing but the angle, the reflex angle POR over here. Okay, this is the angle subtended by the major arc at the center, so which is half of the reflex angle POR. So therefore, we can write the reflex angle POR to be 2 times the angle PQR, which is 2 times 100, which is basically 200 degrees. Okay, so we have the reflex angle here as 200 degrees. Okay, so that's the reflex angle POR, and from that we can now calculate the angle POR. So angle POR is equal to 360 degrees minus the reflex angle POR, because the total angle here should be 360. So we have the reflex angle as 200. So the angle POR, which is the angle subtended at the center here, should be 360 minus 200. So which is equal to 360 degrees minus 200 degrees. So that gives us 160 degrees. So we get this particular angle over here, which is this angle over here, as 160 degrees. Let me write that properly. 160. Okay, so we have this angle POR as 160 degrees. Next, what we notice is that we look at the triangle POR, okay, which is the triangle in the center here, the small triangle in the center. So we have this triangle where OP and OR are the radii of the circle. So that means this is an isosceles triangle. So therefore, the angles opposite to the equal sides must be equal. That means angle OPR, which is this angle that we have to find, and the angle ORP, which is this angle over here, they must both be equal. Okay, so the first observation we notice is that in triangle POR, we notice that OP equals OR, and these are the radii. Okay, so therefore a triangle POR is an isosceles triangle. So therefore we have angle OPR is equal to angle ORP. Okay, then that's because of the isosceles triangle. Okay, and then we have the other property of the triangle, that the sum of the angles in a triangle should be 180 degrees. So that means in the triangle POR, angle POR plus angle OPR plus angle ORP should be 180 degrees, and we know POR is 160 degrees plus OPR plus angle ORP. Let me write those clearly. ORP should be 180 degrees. So that means it gives us angle OPR plus angle ORP should be 180 minus 160, which is 20 degrees. Okay, so we get this part, and we also know that OPR is equal to ORP from this relationship over here. OPR is equal to ORP, and their sum should be 20 degrees. So therefore each of these should be 10 degrees, right? So we can write this as OPR plus angle OPR equals 20 degrees. Why is that the case? Because of if I call this as equation number 1. Okay, we can write this from equation number 1. So therefore we have 2 times angle OPR is 20 degrees, and therefore angle OPR should be equal to 20 divided by 2, which is 10 degrees. So we have our answer for the angle OPR, which is this angle over here, and that's equal to 10 degrees. Okay, which is what we are asked to find in the question. Okay, that solves the problem. And basically you have to be clear in this, that when you're looking at the angle subtended at the center and the angle subtended on the circumference of the circle, we know that the angle subtended at the center is twice the angle subtended at the circumference, but you have to be clear that the angle subtended by the whether it is the angle covered by the major arc or minor arc. Okay, since the angle given here is the angle subtended by the major arc, so when you're looking at the center also, you have to look at the angle subtended by the major arc, not the other way around. Okay, so you have to look at the reflex angle in this particular case. So the reflex angle POR will be 2 times the angle PQR given to us, and from that, once we get the reflex angle, we are able to now calculate the angle POR, and from the angle POR we can consider the triangle POR, from which we can determine that it is an isosceles triangle, and therefore angle OPR and angle ORP must be equal, and the sum of the angles is 180 degrees, so therefore we get each of them as 10 degrees each. Okay, so that should be clear enough, and we will solve another example in the next video.